Hello guys, welcome back to the channel, and today we're going to solve this Leetcode question, which is minimum common value. And in this question we're basically given two integer arrays, which is nums1 and nums2. These two are sorted in non-decreasing order. Non-decreasing order is nothing but ascending order, right? And then we need to return the minimum integer common to both arrays. And if there is no common integer amongst both arrays, we just need to return -1. Note that an integer is said to be common if both arrays have at least one occurrence of that integer. The problem statement is very easy to understand. We're just given two arrays, nums1 and nums2, and we just need to return the common element, which is the smallest. We just need to return the smallest common element in both the arrays, right? So if you look at these two arrays, what is the minimum common element in both the arrays? You can easily tell that it is 2, right? One is one is the smallest, but one does not present in this array. So one cannot be the minimum common value, right? So we go to 2, and 2 we see that 2 is in both the arrays and 2 is the smallest element. And in this array, in these two arrays, what's the minimum common element? Still 2, right? 2 and 2, right? So the main thing that we need to take care of that is both nums1 and nums2 are sorted in ascending order. So using this idea, we can solve this question very easily, right? So let's see the approach one. What's up? The approach one states that for every element in array 2, check if that element is in array 1 or not. If it is present, then it is the minimum element, right? So let's try to understand this with an example. So let's look at this example. In this example, we have two arrays, and this is the array 1. This is the array 1. This is the array 2. Array 2, right? Now what I'll do is I'll take this element. We know we already know that this array is already sorted in ascending order, right? So the leftmost value is always the smallest one, right? So if I could find the element which is on the leftmost value in this array, then it is the answer, right? So what I'll do is I'll take a pointer here and I'll just keep on going in this direction, and I'll check each element if at least one of the element is present in this array or not. If one of the element from the left is present in the array, then it is the smallest common value, right? So using this approach, let's look at how we can do that. So I'll be at 1 and I'll go through the entire array and check if there is 1 in this array or not. So I'll come here and I see that 1 is present, right? So it is the minimum element. So, suppose let's say we don't have 1 here. So I'll take this and I see that 3 is also present at this point, right? So 3 is the minimum element. So in this way we can solve this question. So let's look at the time complexity. I'm not going to write code for this. I'm going to write code for the next approach. Basically, what we are doing is for every element in array 2, uh, we're iterating the whole array 1, right? So if we assume our length of the array 1 is order uh, let's say the length of the array 2 is m and the length of the array 1 is n, then the time complexity will be m into n, right? And the space complexity is, since we are not using any extra space, the space complexity is order of 1. So if you tell this approach to an interviewer in an interview, he might not be happy with this time complexity because it is huge, right? If you look at the constraints, we have the constraint right here. The constraints are till 10 power 5, right? So it can be 10 power 5 into 10 power 5, which can be 10 power 10 operations, right? So which gives you time limit exceeded. So we need to optimize the solution. How are we going to optimize the solution means we need to identify what we are doing wrong in this approach. Here in this approach, for every element, we're just traversing through the whole array in order to find if that element is present in the array or not, right? So because of that, our time complexity is getting very high, right? So in the second approach, I'll use a hash set. So using hash set, I can check if a element present in the set or not in order of one time. In order of one time, right? So what I'll do is I'll store all these elements in my set. 1, 2, 3, 4, 5. And I'll basically do the same thing again. I'll check for 3. Is 3 present in this array or in this set or not? But what's the difference is here the array takes order of n time to check if the element is present or not. And we can also apply binary search, which takes order of log n, since the array is sorted. But we're not going to do that because set gives us order of 1 time complexity, right? So for every element, I'm going to check if the element is present in the set or not. If the element is present, then I'm going to return the element, right? So I'll check if 3 is present or not in this set. It is present, right? So I'm going to return 3. What if we have something like we have the second array is something like array equals to 5 comma 6. Let's say the array is like this. For 5, I'll check in the set. It is present, right? So it is the smallest value. What if there is no 5? There is only 6 in the second array. Then I'll try to check if 6 is present in the array or not. It's not present, right? And I'll check for more elements, but I find no elements, right? So at this point, we find no common element. Then the answer is -1, right? Now, let's look at the time and space complexity of this. The time complexity is for every element, we're checking if the element is present in the set or not, right? So which is order of, oh, the length of this array is m, right? M into order of 1, right? Which is order of m. And space complexity is order of n, right? Let's say the length of the array is n. Since we are storing n elements in our set, the space complexity is order of n. So even even this approach is not good for an interview because the interviewer might ask us to remove this extra space that we are using, right? So when the interviewer asks us to remove the extra space that we are using, we can further optimize it by using a two-pointer approach. Pointer approach. So basically, I'll come up with an example. So let's look at this example, guys, to get a clear idea of this approach. So initially, what I'll do is I'll take a pointer here, and I will take a pointer here, and I know that if these two elements to which these two pointers are pointing are equal, then it is the smallest element, right? So what I'll do is I'll keep my pointers at 0th index of every array. Now I'll check if these two elements are equal or not, right? These two elements are not equal, right? So what I'll do is I'll move my smallest pointer. Since 1 is less than 3, I'll move my smallest pointer because if I move my larger pointer, this will never be equal to 1, right? But if I move my smaller pointer to the maximum side, if I move my smaller pointer to the maximum side, then I can make these elements equal, right? So that's why if my this element is less than this element, then I'll move my first pointer. So if I move my first pointer, it will be pointing to this, right? So 2 is again less than 3, right? So I'll again move my, let's say this is I pointer. This is I pointer and this is j pointer. And if you look now, 3 is equals to 3. So the minimum element will be 3, right? So let's take another example. So in this example, I'll keep my I pointer here. I'll keep my j pointer here. So what I'll do is I'll check if these two elements are equal or not. These two elements are not equal, right? So I'll move my small pointer. Small pointer means the pointer which points to the smallest element. So here 0 is less than I, right? So I'll move my j pointer instead of moving my I pointer. So I'll move my j pointer here. So this is my j pointer, right? Now I'll check these two elements are equal or not. These two are not equal, right? So I'll move my small pointer, which is 1 less than 3, right? So I'll move this pointer. So my I comes here. Now I'll check are these two elements equal or not. These two are not equal. And again 2 is less than 3, right? So I'll move my I pointer. So my I pointer comes here. And now I'll check are these two equal? They're not equal, right? And if you look carefully, 3 here 3 is less than 4. So I will move my J pointer. J pointer. And if you look carefully, 4 is equals to 4. These two pointers are pointing to the same element, right? So at this in this array, the answer is 4, right? So this is the approach, and let's look at the time complexity. The time complexity is at most we're going to traverse. In the worst case, we're going to traverse through the entire array, and we're going to traverse through the entire array, right? Let's say the length of the array is n, and this length is m. So it can be n plus m, since we are traversing only once. N plus m, right? And if you look at the space complexity, it is order of 1, right? Since we are not using any extra space. So let's try to code this up. So initially, I'm going to take I as 0 and my j as 0, right? So my loop goes till I less than nums1 dot length and my j less than nums2 dot length, right? And as I have already said, I'll check if these two elements are equal or not. Nums of I is equals to nums of j. If these two elements are equal, then either any one of them is the answer. I can either send nums of I, nums1 of I, or I can also return nums2 of j, right? Sorry, this is nums2. Else if my nums1 of I is less than nums2 of j, if my left value is less, then I'll move my left value. If these two are not the cases, then I'll move my j value, right? J pointer. And at the end, I'll just return -1. If I can't find any common elements, I'll return -1, right? That's it. Oh, the spelling is wrong. Uh, let's try to run this. Let's try to submit this. Yeah, it's getting accepted, guys. And if you find the video helpful, then give a like to the video, guys. Thank you.